In this problem, we're told that we have a weak base with this Kb of 8 times 10 to the minus 7, and what concentration of this base will produce a pH of 10.35. Okay, so the first thing that I want to do is I want to write a generic equation for the dissociation of a base in water, and any weak base is going to react with water and accept a proton from water to form its conjugate acid and hydroxide. Okay, now we are told that we want a pH of 10.35. So if we have a pH of 10.35, our POH is going to be 14 minus 10.35, which would be 3.65. If I know my POH, I can calculate the concentration of hydroxide that we're looking at. It's going to be 10 to the minus POH, or 10 to the minus 3.65, which is 2.24 times 10 to the minus 4. So in a typical ICE chart, we're usually solving for X as the concentration of one of our products. But here, our unknown is going to be our initial concentration at the base. So if we set up our ICE chart, our initial concentration of the base is going to be X, our two products are going to be 0, and we know that our concentration of hydroxide and conjugate acid are going to be this value, and that is going to be the shift that occurs to get to equilibrium when the base is first dissolved in water. So I'm going to plug all these values from my ICE chart into my Kb expression. So my concentration of my conjugate acid and base is 2.24 times 10 to the minus 4. And then my concentration of my base at equilibrium is going to be whatever that initial concentration is, minus 2.24 times 10 to the minus 4. Okay, and these numbers are the same because of the stoichiometric coefficient here is 1. So for every molecule of base that reacts, I get one molecule or one polyatomic ion of my conjugate acid and one hydroxide. Okay, so then I just have to do some algebra. I square my numerator here, and then I multiply both sides by my denominator. So then I just have to distribute my 8 times 10 to the minus 7 to each of the terms inside my brackets here. So I get 8 times 10 to the minus 7x minus 1.79 times 10 to the minus 10. So I add 1.79 times 10 to the minus 10 to both sides, and that slightly changes this value here. And then I divide both sides by 8 times 10 to the minus 7 to solve for x, and when I do that, I get 6.29 times 10 to the minus 2. So that is what my initial concentration of base has to be to get a pH of 10.35.